All right, there it is. Sweet. So here's our 7-1 assignment that we're going to go over. So exciting. It's all about similar shapes. Admit. Okay. So similar shapes, recap, just means that they have the same angles, so that's nice, but they have proportionate side lengths. So people tend to just believe that they should only have the same side lengths, but they don't. They're proportionate, which is lovely. So that just means that they're going to have a number that you could multiply them by, and then it would get to the next shape. Perfect. It's called a scale factor. Okay. Right. Uh-huh. You use Google Meets in advisory? I didn't know that. Okay. All right. So, first thing here, we're going to identify the pairs of congruent angles and corresponding sides. So, do we know what is going to match up? I don't know. Let's check. All right. So, the angle with nothing on it is going to have to match the angle with nothing on it. So, angle W is going to be the same as angle P. Super. Then the angle with one tick mark on it is going to have to match. So, angle M with angle U. And then the last one with 2 dots or 2 tick marks, angle markers, angle V is going to have to match up with angle N. Someone's saying something. I assume there's some sort of app or sticker involved. Okay. This is going to be distracting for those watching. Okay. So those are the angles. Super. And now we're going to do corresponding sides. Awesome. All right. So corresponding sides do have to be surrounded by the same angles to match up the sides. So for instance, from angle 1 to 2, that side is going to have to match up. So angle with 1 tick mark to 2 tick marks, meaning MN, is going to have to be in proportion with VU or UV. The next one, let's see, from the angle measure not mentioned to the 2 tick mark. So here are going to have to match up. So let's see, I put MN on top, so PN over VW. And again, as you're doing this proportion, you do want to make sure that you keep the same shape on top or bottom. So in this case, the smaller one I put on top, fine. You could flip them, but as long as it remains the same the whole time, then you're good. And then the last one is from the 0 tick marks to the 1 tick mark. And so MP is going to be in proportion with WU or UW. All right. So those are all the corresponding sides. Super. So these all compare, and then if I knew their lengths, which I do, I'd know also the scale factor that's there. So it doesn't necessarily say anything about making that number, so cool. All right. So we move on to the next one here. And we're going to list all the angles that are the same. So let's see, angle K has 2 tick marks and angle C has 2 tick marks. So little arc marks. So angle K is going to be congruent to angle C. Also, this happens to be, by definition, a kite. And so in that case, all of the ones that are not mentioned are actually the opposite angle that is congruent. I mean, this one, of course, has 9. They all have 97 in them, so there you go. But angle D is going to be equal to angle B within its own kite, and then angle J and angle L. I hope that Marcus is doing a good job of writing down this assignment so you get points for it. Thanks, Marcus. Okay. I'm just saying. Yeah, that's kind of what I was saying. All right. So then we also have DC, which goes from an empty side to an angle mark, and then also LK, which goes from an empty side to an angle mark. And this one, it doesn't actually matter which one is with which, because it's going to be the same 6 and 4. So I'll just do DC with LK, and then that is going to equal the same of BC and JK. So these are all the same length. And then that's going to be the same idea for the next one. This measure of 8 and this measure of 8 is going to be in proportion with the measures of 12 here. So DA and AB, and those are in proportion with HJ and HL. And again, the order of within the blue and within the purple doesn't necessarily matter because they're all the same, so they're interchangeable. So I could have switched HL and HJ, for instance, if I felt like it. All right. So that's the idea there of identifying the pairs of congruent angles and corresponding sides. So we are going to use this in a proportion to solve. So that's kind of the whole idea here, is that once you identify something is similar, then you can go ahead and use this proportion to solve things. So very exciting. So here we go. We're going to determine whether polygons are similar, and if so, we're going to write the similarity ratio and a similarity statement. So the similarity ratio has to do with the fact that they list this one first and then this one. So it's going to talk about this one as the numerator of the fraction and this one as a denominator of the fraction in a similarity ratio. So in this case, these are rectangles. Oh, well, that's good to know, because then we know that this side is 90, this opposite side is 135. We know that all of the angles are 90, and we know that this side length is 30. So because it said rectangle, we do know how to fill in all the rest of that. And so because of that, all the angles are congruent, and all the sides are supposed to be proportionate. So let's find out what that proportion is. So we just need to pick one set of numbers. So I'm going to use this one again as my numerator and this one as my denominator. And it doesn't matter if I picked 135 over 90 or if I pick 45 over 30, because since they are all equal and proportionate, they all work. So 45 over 90 reduces to 3/2. And does this one reduce to? Yeah, it does. 3/2. How nice is that? So either way, your similarity statement, your similarity ratio is this guy. And then your similarity statement is going to be identifying the letters that match up. So for instance, AD is a side length of 45, and that should be in relation to EH, because that's going to form our similarity ratio. So don't do AD and then EF in the same order of the letters, because then you're going to have a ratio that doesn't work. So looks like we could probably just do alphabetical order, right? A, B, C, D. And then EF is along the long side. FG is the shorter side. Yeah, so the alphabet works for this one. Sometimes on purpose, we don't do that so that you actually have to think about what thing goes after the other. So don't get too caught up in it being in alphabetical order. And this is our similarity statement. So those of you looking for your, short answer, you need your similarity ratio from this fraction, and you need your similarity statement. So I suppose you didn't even need to make this. Can I delete the? Well, I can delete the highlighting. How exciting is that? All right. Just finding out too many things. Okay. So those are the only things for number 4 that you would need to write down. But of course, knowing all the rest of these little things that I wrote down is going to help you get to those highlighted proportions. All right. All right. So next one, we've got triangle Rmp and triangle Uwx. So not much when it comes to the definition of a triangle here, other than 3 sides. So angle R and angle X are going to match up. So when we think of writing a similarity statement, R is going to want to be in the same place as X. And then 2 tick mark side here for M. So M would be next, and then also this 2 tick mark side, so W. And then 1 tick mark and 1 tick mark for U and P. So this is our similarity statement, just like the previous one. Can I? Nope, I can't. Just gonna type that because similarity statement is hard to write with. Well, type and write. All right, and then now that we know that they have a 1 tick mark, 2 tick mark, and a 0 tick mark side that match up, do we have proportionate sides? Let's see. So between the 0 and 1 tick mark side and the 0 and 1 tick mark side, we have a proportion of 4 and 6. And we're going to see if that equals the next setup, which is between the 1 and 2 tick mark side. And so we have a proportion of 10 over 15. And we're trying to see if that also equals the last setup, which would be the 2 tick mark to 0 tick mark side. So 8 to 12. So we just need to double check if all of these actually reduce to be the same value, which, let's see, 4/6 is actually 2/3, and 10/15 is 2/3, and 8/12 is also 2/3. So they are equal, and so therefore we do know that they're going to be similar. And we've got our similarity statement, and our similarity ratio is 2/3. That's excellent. All right. So, forgot what I was going to say. No, I know. That wasn't from me. It was from Tim/Marcus. Okay. All right. So again, Marcus and all of you that are distracted by Marcus, hopefully you at least wrote the similarity statement and the similarity ratio coming from these fractions here. Okay. All right, next one. Ooh, so now we're going to use our ratios to identify this painting that apparently they made that is in scale to this little guy right down here. So they made a very large statue of this painting in Goodland, Kansas, because why not? So it's a little Van Gogh picture that's clearly giant. Hopefully it's like attached there, otherwise a big wind might come. Okay, so you lighten the mood, fine. All right. It claims that it has one of the world's largest easels, and it holds an enlargement of a Van Gogh painting that is 24 feet wide and 50. The original painting is 58 centimeters. Okay, so 24 feet wide here, and the original is supposed to be 58 centimeters. And then they say that the one that they have is, we don't know its height, but we know that this one is 73 centimeters tall. And so we need to know what this height measure is in feet. All right, so that means that these are, I assume, rectangles. And so thinking about a proportion that would happen here, I could do the heights on top, and then I could do the width on bottom, and then I would make a column of the statue, and then the original. So what I'm kind of setting up here is like a little box that would match, for instance, the height and the statue of the statue of the height of the statue. Wow. And then the width of the statue would go here, height of the original will go here, and width of the original. But we don't do it necessarily in a box. We do it in a set of proportions or equal fractions. So in that case, we still have these areas that we're filling in where these ideas meet, but we're putting it in a proportion. So I'm going to fill in the height of the statue, which is going to be x because we don't know what it is. The width of the statue is 24 feet, and it's okay that feet is in this one fraction and centimeters is in this fraction. It's just that if the the column all of itself doesn't match, or the row doesn't match, one of them, then we'll be good. So then we need the width of the original, which is 58 centimeters, and then the height of the original, which is 73 centimeters. So again, as long as this fraction is centimeters and this one will ultimately be feet, that's fine, that these ones across don't match, because you just need to make sure that either the rows or the columns match. So how do we solve this? We're going to note that cross multiplication means that x times 58, that diagonal, is equal to 24 times 73. And so 24 times 73 is 1,752. And so in order to be a similar shape, we're going to divide by 58 and get the height that the statue should potentially be. So divide by 58 and we get 30.21. Let me just double check that we have the right numbers, because that was decimal and that just makes it feel weird. All right, it does say to the nearest foot, so 0.21 would mean that we're actually just going to round this to 30 feet. So 30 feet for the height of the giant easel image. All right, woo! So proportions, again, something that you hopefully talked about in Algebra 1, because that was way back then. All right, so now we're going to talk about some similar shapes and if it's sometimes, always, or never happening. So, two right triangles are similar. So if I have a right triangle here and a right triangle here, they're basically saying that they have to be similar. So I could make this right triangle look like this, and I could make this right triangle look more like an isosceles triangle. Whoops, if that was straight. Oh, well, the answer is 30 feet. And then I would definitely put the proportion that you use to solve otherwise. I don't know where you got 30 feet from. Excellent question. All right. So in the next one, again, we were talking about similar, and it turns out that just because one of the angles is right does not mean that all of the angles are going to match that. And so in that case, we're going to say sometimes, in really thick writing. So again, it's only because they have one angle that matches, so yay, but we need all three. So then we have two squares are similar. And let's see, squares are similar. Squares kind of have to be similar because they all have 90 degrees, so the angles all match, and every single side length has to be the same, otherwise it's not a square, and so you're always going to have the same proportion, and so this one is always. So again, because all the angles match up, and then all of the sides have to be proportionate because it would never change. Then we have a parallelogram and a trapezoid are similar. What? Parallelogram and a trapezoid. No. Because a parallelogram needs to have one set of opposite sides parallel, and a parallelogram needs two. So I'm just going to go with never. I can't, on the top of my head, think of any way to meld these together that allows for all the definitions we talked about in our last chapter. So nope. It's hard to say never because that just seems very final. But anyway, if two polygons are congruent, they are also similar. Two polygons are congruent, then they are similar. Yes, actually, it's just that their ratio is 1. Their similarity ratio. Kind of interesting to think about. Okay. And then if two polygons are similar, they are also congruent, and that might be sometimes. Kind of like how a square is always a rectangle, but a rectangle is not always a square. So that's what's happening here. Some things may be similar and congruent, but they don't always have to be similar and congruent. Interesting thing to think about. Super. Then we've got some more critical thinking. Ooh. So explain why any two regular polygons having the same number of sides are similar. That's because of the word regular. Because regular means that all the angles are the same. means congruent angles. And it also means, oh yeah, I can back up in a second, and it means congruent sides. So here are your guys for these ones. It's a very loud car outside. All right. On the idea of never, I can very confidently say that a circle is never a square, but anyway, never is hard to say sometimes. Okay. So, next piece is just understanding the definition of a regular, except in Minecraft. Really? Are circles squares in Minecraft? I suppose they don't have rounded edges. That's scary. Okay. I mean, it's kind of like if I even made a perfect square on this image, it's all pixelated anyway, so it's like all Minecraft. What? Okay, moving on. All right. If you've ever done paint on your computer and zoomed in, yep. Anyway, that was a big thing. If you talk about that with all your advisors, I'm sure they'll understand what I'm talking about. And maybe you've had no internet before and you're like, what can I do on my computer? You can draw. Okay. So, regular, the word, means that there are congruent angles and there's congruent sides. And so, explain why two regular polygons have the same number of sides and are similar. Then there will only be just like, which one? This one. Just like it says two squares are similar, squares are actually regular polygons. So it goes back to number 14. Because basically whatever the side length is that we say for one of the shapes, like 8 or whatever, 8 will always be there in relation to the other one, like 6, for instance. So it will never actually change to 9, because then it won't be regular anymore. And it'll always stay 6. So it'll always be that same 8/6 fraction that you're matching from one shape to the next. So, because the sides never change length and the angles never change length, yay. Explain. It's because this. Majors are annoying. Okay. All right. That's not really a sentence, but I suppose I could make it a sentence. Here you go. Spelling 101? It's more like typing 101. I mean, I guess, but like I spell it in my head, but then my finger like accidentally hit something, so it's all good. I'm fine. All right. So anyway, that's your statement, but because it does say explain, and so this little like weird doodad of explaining doesn't really help. So because regular means that angles and sides are congruent, the ratio will remain constant and the shapes will be similar. I'm just waiting because some people might actually be writing this down. It's cool. Just checking. Oh, we have a few more problems. Okay, just noting. Ooh, by the way, it's noon, so if you happen to have another class that's at noon for some reason, you should go to that, I guess. And of course, this will be posted on HeadRush for you later. Your life is a problem. Tell me about it. We'll probably end up doing something like sometimes, and so it won't really help. We'll only help it in the sometimes manner. All right. Sorry. Okay. Yeah. Life is probably not going to get easier, just to like let you in on a little bit. Anyway. So, I mean, maybe. I don't know. Even if you win the lottery, it's not necessarily going to get easier. Just saying. Just kind of day to day. Okay. So, we're going to find the value of x, noting that, oh my gosh, these things are similar, which means that all of their angles match and all of their sides are proportionate. So, AB, since it's the first two letters, and EF are in a proportion together because of the similarity statement. So 4 and x plus 3, in fact, can equal another set of sides like BC, which are the second two letters, and FG, which are the second two letters. And so now, algebraically, we get to solve this from the geometry that was setting it up. So how do we solve that? We just cross multiply. So we've got 3 that's multiplied by x plus 3, and then 4 that's multiplied by 2x minus 4. Notice that I put parentheses in there, because technically all fractions have parentheses anyway. We just don't put them because how obnoxious would it be to write that for 2/3 every time? You'd just be like, what? Okay, so we don't do that, and therefore sometimes people get confused about how to distribute this 3, for instance. So it is actually going to be multiplied into both of these pieces, meaning 3x plus 9. And then over here, the 4 into both of these pieces, meaning 8x minus 16. Woohoo! And so if we move our numbers with our numbers, ooh, that's a positive 16 that I want to move over. So 3x plus 25. And then I'm going to move the 3x over. Whoa. So we get 25 equal to 5x. Oh my gosh, almost there. Divide by 5. 5 is x. That's all they wanted? Yeah. Find the value of x. All right. So that's all you got to do on the next one as well, is identify which side links with which side so that you can make a proportion to solve. And done. Bye. All right. All right. So, same thing happening here. Let's see. PN is this one. And it must match with YZ. Where's YZ? Oh, they flipped it around, people. Don't get confused by that. All right, so 4x minus 10 is supposed to be over 75. And then in the next one, I have MP, which are the first and last, and so that's going to have to be with XZ, that one. And so you do want to make sure that you put the small one on top, and then the bottom one is the bigger one, or vice versa, as long as you have it on the top together or the bottom together. So you don't want to have put 30 up here for some reason. And then we get to multiply diagonally. So 75 times x plus 5 is going to be part of our new problem, and 30 times 4x minus 10. So we'll distribute and solve. Oh my gosh, 75 is such a big number. 75 times 5. 375. Sounds about right. And then 120x for this distribution, and negative 300. Wow, how did these numbers get so big? I don't know. Oh, sounds like someone's trying to come in. Hello. All right, so we're going to add 300 to both sides. And get 75x plus 675. I'm doing some math. What are you doing? You want me to move the cat? Okay. Oh. Okay, so someone had to come in. I just need to double check my math of 75 times 5. Okay. I believe in myself. Okay, so we're going to subtract 75x from both sides. And get 675 equal to don't need to be in here. Let's say 25, 50. How am I doing? 45. Yeah. And then divide by 45. Boop. I wonder if 675 can be divided by 45. I assume sure. Look at that. 15. And that is why the book made the problems and not me. Because I would have just picked random numbers and then realized that it made like 14.24 or something. All right. So that's that one. Any questions on our setup on that one? If you're thinking of writing minimalist work, again, that would be where you need to start, at least showing me that you could set it up and then that you could solve to get that answer. Talking to you, Marcus, you should write that down for number 19 and that down for number 20. He's gone. Oh my gosh, come on. He probably had to go shave because he had facial hair. Okay, moving on. All right. Oh my gosh, 2 more problems. Does anybody still need this one? Hearing none, I shall move on. All right. Oh, so this one I think they just want you to solve for x as well. It was in a different format. There it is. So they're telling us that some sort of parallelogram, JKLM, is similar to another parallelogram, NOPQ. And so if the measure of angle K is 75, we need to name 2 75-degree angles in NOPQ. So interestingly enough, I don't even need to draw a picture because K is the second letter here and O is the second letter here. So angle O is going to have to equal angle K. Because otherwise, why would you write it in that order? That's the whole point of writing in that order. Then I guess I'm going to draw one picture, but that's only because of the naming of shapes. If you were going to name this parallelogram, you cannot just like randomly put letters anywhere like that. It does in fact have to be in an order. So wherever it is that you decide to put the first letter, the sequence after that in a circle has to be all of the rest of the letters. So if you want to go clockwise or counterclockwise, that's fine. So if I go N and this is O, then this has to be P and this has to be Q. So because of the fact that this has to be in an order of a circle at some point, O is opposite of Q, and so Q is also going to be 75 degrees. I forgot my equal sign. All right. So all of those, O and Q. And then also technically M, we just didn't say it because they only wanted it in NOPQ. NOPQ. And then I'm going to rewrite this because I can't stand how close it is together. All right, angle O, congruence equal angle Q. There it is. Perfect. All right. Not really, but there you go. All right, so again, what do you want to write down? That. Okay. All right, you can draw your picture. I know, huh? I mean, some of you might be trying to write these circly things in this shape, but you really don't. All right. So moving on, whoops. Oh my gosh, what a calligraphy pen? I am so doing that in the next one. Okay. I did not even know that was a thing. Whoa, okay. A dining room is 18 feet long and 14 feet wide. Good. Okay, so boop, boop, boop. Dining room. And we've got 18 feet long and 14 feet wide. Boop. On a blueprint for a house, the dining room is 3.5 inches long. Oh my gosh, other color. So 3.5 inches long. And then we don't know to the nearest inch what is the width of it on the blueprint. So that's exciting. So I've literally already kind of set it up as a proportion. Just gonna get my, there's actually a crayon option, or there used to be. Oh, yeah, there it is. Oh my god. Okay, I'm totally gonna do it in crayon now, guys. Okay. So that means that I'm going to set up, that's really bad. 3.5 over 18. And I'm going to set that equal to 3.5 matches with x, so x over 14. All right, so we're going to cross multiply, boop, boop, which means that 3.5 is going to be multiplied by 14, and x is going to be multiplied by 18. Boop. And so what is 3.5 times 14? Don't know. 49. So apparently we've got 49 equal to x times 18. Oh, I think we're going to get a decimal here. And so if we divide by that 18 that's sitting there, 49 divided by 18 is 2.72 repeating. Boo. And so x, or the width of that, is going to be that terrible decimal. Let's do creative pen. Ooh. 2.72. We are talking about inches. All right. So what was it that you needed to write down from here? This piece, and definitely this piece, because then you've shown me that you know how to set it up and get the answer. Very exciting. Yeah, you like the grant? I mean, it's a little hard. Yeah. I wish I could, like, make it thicker. Well, like press harder? Is that... I can't press harder because clearly that's like... Oh, I guess I could just write over it, which is kind of how you do it with crayons anyway, so... Okay, I'm done. All right, so that is the end of that assignment. Thank heavens. And now I'm going to stop recording so you can show me your assignment. Where is it? That's an excellent idea. Okay, screen.